Welcome to www.happynumbers.org. We're continuing with our lessons in polynomials. And today we're going to look at working with polynomials when we have exponents and we need to multiply. When we're multiplying, exponents in multiplication. It's a very simple rule here. To multiply terms, algebraic terms, with like variables, we add the exponents. Now I want to make a distinction here. The variable here is x, and the variable here is x. The variable term here is x to the fourth. The variable term here is x to the third. But we are not dealing with variable terms. Remember, the definition doesn't say to multiply terms with like variable parts. It says like variables. So the exponent may be different, but that's okay. The variable is the same. The variables are like. The variable parts are different here because the variable part here is x to the fourth. The variable part here is x to the third. But we're only concerned if the variables are alike, and these variables are. So, to work this problem, we certainly could do this. X to the fourth is x times x times x times x times x to the third, x times x times x. This is x to the fourth, and this is x to the third. And then we could count them up. 1, 2, 3, 4, 5, 6, 7 equals x to the seventh. So if I multiply x to the fourth times x to the third, my answer is x to the seventh. But a simple way of doing that is just to add the exponents. The variables are the same, so I write the variable, and the exponents are 4 plus 3. So if I add 4 and 3, I get x to the seventh. So that's the shortcut. So when you're multiplying terms that have like variables and exponent, you add the exponents. That's all. Very simple. Let's look at another example. Let's look at y to the third power times y to the second power. By the way, you might see this written, although it's rare, like that, like a traditional vertical multiplication. Usually it's always written this way. Well, our variables are both y here. The variables are alike. The variable parts are different because this is y to the third and y, but we're not interested. The variable is the same. Well, the rule is we can add the exponents. So y to the third times y to the second is y to the fifth. And if we wrote it out, you could see y times y times y, that would be y to the third, times y, that would be y squared, would be 1, 2, 3, 4, 5, y to the fifth. All right. Pretty simple. One more example before I turn it over to you. Let's take w to the second power times w. Well, our variables are the same, w and w. Again, our variable parts are different because we have w squared and just w to the first power, but we're not interested in that. The variable is the same. So, we can add the exponents. 2. Remember, there's an exponent of 1 here. We don't write it. So, w to the second power times w is equal to w to 2 plus 1 w to the third power. That's all there is to the skill set. So you should be all over that. Let me give you some problems here. Let's give you x to the third times x, and we'll give you a to the second power times a, and we'll give you b to the third power times b to the 5th power, and we'll give you c to the 2nd power times c. All right. Put your DVD on pause. Go ahead and work those problems. Turn your DVD back on again, and then we'll go through the solutions. Okay, let's take a look. Our two variables are the same, x. So we just add the exponents. The exponent here is 3. The exponent here, remember, is 1. So that gives us x to the 4th. X to the 3rd power times x is x to the 4th power. A to the 2nd power times a. The variable parts are the same. So it's a to the 2 plus, remember this is 1, so this is a to the 3rd. B to the 3rd times b to the 5th. Our variables are the same, so it's b, my bad. It's b to 3 plus 5, which is b to the 8th. And here, c to the 2nd times c. Our variables are the same, so it would be c to 2 plus 1. Remember the exponent is 1 here, which would be c to the 3rd power. Well, good. Good. By the way, let me just speculate here for a minute. What do you think about this? X to the 2nd times x times x to the 4th. What do you think that would be? What do you think the solution to that would be? Well, if you said, well, my variables are the same, so it would be x, and it would be 2, because that's 2, and 1 plus 4, which would be x to 2, 3, x to the 7th. As long as the variables are the same, we just add the exponents, and you have to remember there's a 1 as an exponent there. Well, very good. That's all there is to that skill set, so thank you very much. Next, we'll be going on to multiplication of monomials and binomials and polynomials, trinomials, and this particular rule about adding exponents comes into play in the multiplication process. Again, thank you very much.